Hello guys and welcome back to my channel Interview with Bunny, and we are back with another video on our system designing fundamental playlist, and today's topic is DNS, that is the domain name system. So in our last video when we were discussing about the client service architecture or the client service model, there at the very end I have given you a small hint about the DNS. That is when we were discussing about the client service architecture with the analogy of the restaurant, there I have told you that here the waiter is nothing but the DNS who was actually taking the request or the order from you and thereafter placing the order to the correct server or the correct cook at the backend. Means if you are requesting for the Chinese food, then it was going to the cook who is specialized on the Chinese food. Similarly, if you are ordering for an Italian stuff, then the DNS or the waiter was responsible to give that order to the specific cook who is specialized on the Italian stuff. So the main responsibility of the DNS is to map your request with the server who is actually responsible to fulfill. So that was a very brief understanding that I have given you at my previous video. But here in this video, we will be going inside the DNS system, means we will see in detail that what it actually does, because the concept that we had discussed about the DNS on the last video was very high level. That was just to give you an introduction of how our DNS works or what is the real activity of the DNS. But here we will be discussing in detail. So as we have discussed earlier that whenever a particular backend service we are creating who is fulfilling your request, that service should be deployed in a machine which we call it as a server. So on a very simple term, all the requests that are created by the Facebook application on the front end should be handled by the backend server of the Facebook. It should not be that the requests that are coming from the Facebook will go to the backend server of Amazon or Google. Clear? Now let's see how it actually happens. So for example, this is your Facebook server and this is your Amazon server. And here this is the client, the computer from where you are accessing the internet. So you have typed the URL, that is facebook.com. And here your client or your browser knows that on which server you are actually requesting the data. So when you are typing that www.facebook.com, somehow this client or this browser have the knowledge that whenever you are typing this facebook.com, each have to get the information for this server, not from this Amazon server. Similarly, whenever you are typing another URL, for example www.amazon.com, at that time the request should get fetched from this server, not from the Facebook or from any other server. So here if you understand that somehow this client that we have over here, which is nothing but our browser, have the knowledge that on which of the server this service is actually located, means where is the exact location of the server for all this URL that you are typing over here. I hope this fundamental idea is clear. Now what happens is like, whenever you are creating a backend service, for example the backend of the Amazon or something, obviously since you are deploying on the server of the Amazon, so somehow this client which we have over here have to know that on which server this Amazon backend service is hosting. And the way we uniquely identify each and every server is with the help of the concept that is IP, which is nothing but internet protocol, which is nothing but the address of each and every server or every application that is hosted over the internet. So any server or any device that is connected with the internet or to the internet should have a unique IP. So think it like this entire internet is nothing but a globe, and just like each and every location of the earth have a unique address, similarly all the devices that are connected over the internet also have a unique address by which we can uniquely identify each and every devices. I hope this is clear. Now before going into the detail of the DNS, let's first understand that what is this IP and how it is configured. So this IP are of two types. Number one is IPv4 and number two is IPv6. So these are the two types of IP that are present across the internet. So this was the 4th generation of the IP address and this is the 6th generation of the IP. So this V6 is nothing but the version 6. Clear? So what is the difference between the IPv4 and the IPv6? So if you see across the internet, whenever a particular device is registered, there is a unique IP that is associated with that device. So for example, this is the unique identifier of a particular device. So this is the example of how to represent a device with the help of this IPv4 protocol. Clear? So this is nothing but a 32-bit address which is represented by 4 digits, and this number called as the octet over here. So for the IPv4 protocol, we have 4 octet, and to represent each and every octet, we need 8 bits of memory. So here, if you understand that, to identify 4 octets, we need 32 bits of total memory. So that is why total address of this IPv4 is nothing but 32 bits. I hope this is clear, and this is on a very high level. But in this video, we will not go in detail of what is an IP, how these things are represented and all these things, because that will make our video much more lengthier. So in our next video or some video, we will discuss that what is an IP, what is an IPv6. So all these things we will be discussing the pros and cons in detail in some other video. But just to take an idea that what is an IP and what is this version. So this is nothing but the IPv4 version, and this is how it is represented. Now there's another concept, and that is the IPv6, and how it is represented the same way we used to represent for the IPv4, but it has some advanced logic. That is, here if you see, for the IPv4 we have 6 octets. So this is 1 octet. Then in this way there will be 6 octets by which we can uniquely identify a machine with the help of the IPv6 over the internet. Now on a very high level, what is the advantage of IPv4 over IPv6? The number of devices that can be allocated with the IPv4 is quite limited, because this number can vary from 0 to 255. So in this way, for each and every bit, this number can only range from 0 to 255. Clear? So there is only this amount of combination that is possible for this IPv4 protocol. Now, since with the growing internet and with the introduction of the new IoT devices, this number of devices that are getting introduced over the internet is growing over time. And to represent all the devices or to allocate a particular ID to each and every devices, we came out with a new protocol that is nothing but the IPv6, which can generate much more unique IP addresses by which each and every devices can be mapped to the internet. I hope this is clear that what is the basic difference between the IPv4 and the IPv6. Now coming to the main point, that how it is related to our DNS video. So what actually happens that whenever you are creating a service and hosting over the internet, obviously you have to connect the service to the internet. And since you are connecting that service to the internet, so obviously there should be a unique identifier that should be connected to that service or the server, so that over the internet we can uniquely identify that on which server that particular service is located. So for example, this Amazon service is located on this IP address. So this is just a dummy value that I am using to make you understand. I hope this is clear. So the main concept is each and every backend server that are hosted over the internet should have a unique IP or the unique address by which they can be identified. So right now you have understood that each and every backend server have an IP address. Now if you look carefully, what we are doing at the front end, when we are logging into our Facebook account, we are typing that this URL, that is nothing but the facebook.com, and somehow this client or the web browser knows that for this textual thing that we have, which is nothing but the domain as we call, this domain should be mapped with this corresponding IP address. Means whenever someone is requesting any data with the help of this URL, that is facebook.com, somehow I have to get the location of the server where it is located, and the location can be identified by this IP address. So there should be a map between this domain name that the user is typing and the server IP address on which all those services are located. I hope this is clear. So on a very high level, the main functionality of the DNS is to convert a domain name into a corresponding IP address where the backend system is hosted. So if you take this example, the domain name is nothing but a mapping between this domain name and the particular IP address. So this is actually what a DNS does. That is the conversion of this domain name into this IP address. And why it is necessary? Because obviously, since we are dealing with thousands and thousands of URL or thousands of application over the internet, it is not possible for us to remember all the IP address on which a particular server is hosted. So to make it user friendly, we have came up with this concept that for each and every IP, we will give a user friendly name, which is nothing but called as the domain. And the service that converts this domain name into the corresponding IP address is nothing but the DNS. So on a very high level, this is what our DNS is all about. So if you are fine with understanding only this much concept that what is a DNS, so this is what our DNS is all about. But believe me, knowing only this, that our DNS is nothing but that converts a domain name into an IP address is not sufficient, because right now during the interview, interviewer can ask a lot of questions on the concept of the DNS, and at that time, if you do not know in detail that how this mapping is actually stored and how this resolution is actually happening in the backend, then you might not be able to clear the interview. So to make yourself 100% ready for the interview, you also have to know how this DNS thing actually work behind the scene. So right now we will see in detail that how internally DNS is used to do the resolution of the domain name and how it maps a particular domain name with a corresponding IP address. So let's see in detail that how this DNS actually works. Before proceeding further, I just wanted to notify that I have created a very simple website over here so that you get all the contents that I upload on the YouTube on a single platform. So here you can see there are lots of content on the system designing, on the low level system designing. Similarly, here we have the complete graph playlist where we have already 15 to 16 video over here, as well as all the latest contents that I'm uploading on the YouTube. I will keep on updating all those things in this website. This is a free website that is hosted also in a free domain. So do not forget to bookmark this website so that it will be helpful for you to find out all the relevant contents regarding your upcoming interview. So to make you understand that how this DNS works over the internet, I will give you a simple analogy. And if you understand that analogy clearly, believe me, you will get a complete idea that how a DNS internally works, what is the resolution technique by which DNS map a corresponding domain name to an IP, and everything that is required to clear any internet. So let's start with understanding in detail of the DNS. So as I was telling you, the purpose of the DNS is to get the IP address of a particular server or a unique location or the address of a particular person who is living in this world. So to understand this complete DNS with the help of an analogy, what we will do, we will take an example that, for example, you want to meet me in my office, and let's assume that you only know a few things about me, that is what is my name and which team I work at Microsoft. So this is the only thing that you know about me, and with the help of this information only you want to meet me in the office. So let's take an example. You came into my tech park where all the other different buildings are also there. Now what you will do at the very entry of the tech park where the security person is there, you will tell that I want to meet this person who work at the Microsoft office. Clear? So you will go to the security gate and you will ask for the desk number or the exact location where I sit. Now obviously what the security will do? Security will take up his diary or something and will try to see that whether he knows that where I sit in the office or not. So he will first check up his diary and he will try to see that whether that entry is there in his diary or not. So if he knows that where I sit, very good. What he will do? He will directly tell you at which desk location I am present. Clear? Now let's take an example. He doesn't know. So what he will take? He will take you to the information desk, which is nothing but the information desk of this entire tech park. So he will take you to the next person, which is nothing but the receptionist. Clear? So at the reception, what you will do, over there also you will be asking the same question, that where this person actually sits. So here also the receptionist will see his notebook whether he or she knows the address of me or not. Clear? Now if he knows, very good. Otherwise what she will do? She will do a couple of things. Number one, she will go to the building register. So for example, there is another service or another person present who have the information of all the building register. And here what she will search? Since you have told her, I work at the Microsoft building, and since this is the register of the entire tech park, so obviously all the buildings on which the Microsoft tech park is present will be there. So for example, the Google building is on the block C. Now the Microsoft building is on the block A. So since you are looking for the candidate who works at the Microsoft building, so she will have the information that on the block A this building is located. Now what she will do after she got this information that the person whom you are requesting located at the building A, she will go to the building A receptionist. So it is one step ahead. So this will be the next receptionist, that is the building A receptionist. Now once she goes to the building A receptionist, she will be asking the same question that whether you know this person or not. Now since she is already at the Microsoft building, she have to tell that on which team I actually work. So since I am working on the security domain or the security team, so she will be asking that where this exactly the security team sit on that floor. For example, on the block A building, there are multiple floors where each and every team sits. And since I sit on the security floor, so this receptionist can give the idea that, for example, Intel security team sits on the 5th floor, all the co-pilot team sits on the 7th floor, and so on. So since you are looking for me who works on the security domain or the security team, so right now the receptionist got the idea that I work on the 5th floor. Now what she will do, she will go to the 5th floor and will ask the receptionist of the 5th floor that what is the desk number where I am actually sitting. So the next third call she will be going, that is the 5th floor receptionist. And once she is at the 5th floor, she have right now all the information about me. This 5th floor receptionist can give the exact desk number. So for example, 761. So which is nothing but the IP address on which I am deployed or I am sitting. Clear? So this is actually what the entire DNS thing all about. Now with this analogy, I will be telling you that how internally this DNS is entirely built. So the first person whom you have asked this question, that is the security person, is nothing but your browser. It can be Chrome browser, it can be Edge, it can be anything. So whenever you are typing over the browser a particular URL, the first question you are asking that for this URL, what is the IP address of this URL? So what the security person have done, the first thing it have done is like it have checked the internal notebook whether this person have the entry or not. So this is nothing but the local browser cache. So the first thing the browser does to get the IP address is it searches that whether the mapping of this URL with this IP is present on the browser cache or not. If it can find it, very good. From there only we will return the IP address. And if it is not present, it will go to the next step. That is, we are going to the next receptionist, that is the tech park receptionist. So on the term of the DNS, this service or this system is called as a recursive resolver. Clear? Now once the request comes to this resolver or the recursive resolver, what we did, we went to the building register. Now what this building register? This is nothing but the root namespace. Means this service is called as a root namespace. Means the responsibility of the resolver is to first ask this root namespace that whether you know the IP of a particular domain or not, and what this namespace return, it have returned the block where this particular company was located. Similarly here also, what this root namespace return, it returned the TLD name server, and TLD stands for the top level domain, which is nothing but the building or the block where a particular address can be found. I hope this is clear. Now what we were doing, we were going to the next receptionist, that is the block A receptionist. So this is nothing but our TLD name server, which have all the information of the building, that is on that building on which floor which teams are actually sitting. Now from there, once we get the location or the floor of the particular person, what we do, we went to the next receptionist, that is the floor receptionist. And this floor receptionist is nothing but the authoritative namespace, which have the exact location or the exact IP where I actually sit. So this is exactly what this entire implementation of DNS all about. So whenever you are actually searching for a URL for the first time, these many servers are internally hit and then only the entire web page comes to you on the display. So from here, at the last step, what we are returning the IP address to this recursive resolver. So the final step is that the IP address is returned over here. Now what this recursive resolver will do, it will take the note that for this person, this is the disk ID in the local cache, or this is the IP address of the corresponding server, and it will return it to the security also. And also what the security will do, the security will update its local cache with the corresponding IP address of the server, so that in the next time, in the near future, whenever you are trying to hit this facebook.com again, it does not have to go through this entire process of finding to get a particular IP. I hope you are thoroughly clear that how a DNS is actually resolved in the backend. So here you can see that this is quite a complicated thing to implement, and if you understand that the loading time of each and every URL is in milliseconds, so all these things have to be resolved within 100 to 200 milliseconds. That is the maximum latency a DNS can take. So you can understand that this is quite complicated, and that is why there are a lot of caching that are happening over here. Now what is the caching and everything, that we will see in some other video. Now since you have understood that how internally this DNS actually works, I will just give you a screenshot over here to make you understand that exactly that what is the return type of each and every name server that we were discussing over here, so that it will be easy for you to understand. So just pause the video and understand that how internally the caller going to a particular service, and what is the return type of each and every service, and how internally we are going and finding out the IP address of a particular domain name. I hope you have thoroughly understood that what is a DNS, what is an IP in a very high level, and how it actually behaves. Now one more small things I just need to tell you. Here if you look carefully, whenever we are building an application, it is not the duty of the application to do this DNS call. Rather, it is completely responsibility of the web browser to do all these things. So we as a developer do not have to write any code for this DNS resolution. This is completely served by the browser that you are using. And the first level, this one, that is the recursive resolver, this is normally placed at the ISP level, means who is providing you the internet. Because whenever you are making the calls via internet, the ISP is the first thing that is getting hit. So it first checks the ISP cache whether the particular IP of the domain name is present or not, and if it is present, all these things are basically skipped. I hope this completely makes sense that how this DNS resolution actually works. Now since we have understood that what is a client, what is a server, and how a particular server is deployed over the internet, how we identify a particular server with the help of an IP address, now let's go into a bit deeper. So now what we have understood, that here we have a client and here we are having a server, and this server have a IP address. Now the next question is, since we have got the IP address of this server, now the next thing is that as a client, we have to request the data from the server. Now since this is our internet, there should be some protocol by which a client requests data from the server. And the most commonly used protocol is nothing but the HTTP or the HTTPS protocol. So what this protocol all about, and how a particular client talks to a backend server, all these things we will be seeing in our next video, where we will be seeing in detail that how the connection gets established between a client and the server, and what are the different protocols that are available, what are the use case of each and every protocol, and we will go in detail that based on what criteria we should be using a particular protocol. So see you in our next video, where we will be seeing that how a client and the server actually talks over the internet. So see you in our next video. Thank you.